In this video, I will show the main routine for power-dependent measurement, single channel measurement using TxtShuffle or Shuffle by Power program. The program is user interface is heavily loaded. However, for main routine, you need to use only fraction of this. Starting from the first step, you have to have your all data files from the measurement into one folder, and the main files that we will use are average load, the one with the average load suffix, already averaged files. Here I need to choose 2 column files for all the latest files, and then I click browse. I go to the right folder. In this case, I prepared the test dataset, power dependent. I choose any of the average load file, for example, this one. I click open. When I click open, it does not open the file, it just changes the file name, and then for power, I need to remove the .txt and last two. Some other versions of TxtShuffle, if I'm not mistaken, the latest version that also includes the functionality of shuffle by temperature. It has also suffix, but it should be empty in this case. Actually, I can show that both of them will work without this and with this. Then the first file is 0, due to 0 is first rotation. The last file is 40, so total I have 41 file. The reference power in milliwatts is the power that was recorded using the power meter. For example, is 170. And by default, with the last measurement coefficient 1, power offset 1, and use voltage as reference unchecked, this power reference will be applied to the reference value of the second channel, which is in case of one channel measurement, the second channel is by default is reference channel. For example, let's look at the last rotation, which is from where it will get the reference voltage. You can see that in the header it has this value 4.85. It will be the value that will be used, meaning that it will calculate a proportion that 4.85 stands for 170 milliwatts, then let's say 2.43 stands for 85 milliwatts. If this 170 stands for another voltage, I click use voltage as reference as 5. Other options, coefficient and power offset, are not used. They can be used for additional adjustment of power. However, in the main routine, you don't need it. Power offset simply moves entire scale by, for example, 5 milliwatts or 10 milliwatts, or let's say minus 10. And last measurement offset acts as a coefficient. If your power, let's say every increase in volts, for example, if my last measurement was 5 volts and I think that it's 170 watts, milliwatts, but in reality is 85, then I need to input 2 coefficients, so to decrease everything. However, usually you don't use any of those options. So in the main routine, only one power reference. Then after filling these 3 files, first files, number of files, reference power, you need to fill these 2 text boxes. Align 0 by first measurement using endpoints, and subtract and divide to get delta R by R using this amount of points. You need to get how much points you will use. For this, you plot your data, and then you choose some amount of points before 0. In this case, it's 2000 something, so I will use 2000 points to align 0. After I choose how many points I have to use to align, I need to use Shift 0x. Shift 0x stands for time delay 0. It's when the pump arrived at my surface of the sample. So in this case, I will put it 1.85 to shift my data, because this 0 is not the same 0 as 0 delay between pump and probe. So I have to shift minus 1.85. Then for the main routine, I did everything. Optionally, there are some calibration options, which is I'm not going into details, but I will mention it in the overview video. Once I feel it, I can open files. During the opening, it should already do pre-processing of power and alignment. Then I open, I click done, and for the main routine, I always use equidistant regression, meaning you should check box equidistant equal distances and save files regression. Depends, if you want to have it in the Igor Pro format, you have to save it without X. If not, I just click save and the file starts processing and then saved. Then I click import to see what did I save. And as you can see, the resulting file is just one file, entire table with all of the power in the header. The last one is 170, exactly as we put. The X is shifted 185. And then let's plot it. So it's delta R by R from 0 and some dependence. Important to note that for two temperature model, you want to recalculate it in fluence. So for two temperature model, you need to change it to fluence to add parameters of laser frequency, of beam radius that you should know. Then you need to open again because it pre-processes, and then you save regression. So for power, there are two options, either to make it in power in milliwatts or in fluence. So I will open it in the another window. As you can see that here I see that the values of S and Y, which is explained in the Igor Pro video, much lower, and they stand for initial and final fluences. So, and here you have exactly the same data, exactly the same process, and right now it's in fluence. In millijoule per centimeter square.